When you know how to factor quadratics, it actually opens a whole new world of factoring because we have something else called quadratic forms. And these are expressions that don't look like quadratics at first glance, but with a little substitution of variables, you can actually write it as a quadratic. So let's look at an example here. We've got x to the fourth plus 5x squared plus 6. And you'll notice that we've got three terms like we're used to with quadratics, most quadratics. And the first term, the variable portion, is the square of the second term variable portion. What that means is if we can do a little substitution, I'm going to introduce a new variable. I'm just going to call it u. It doesn't matter what variable you use, just something other than the variable that you have here. And what we're going to do is set u equal to x squared because that's the variable expression in the second term. And then notice that u squared, well, if I square x squared, we multiply the exponents, and that gives us x to the fourth, which is what I have right here. And so I can write this expression now in terms of u as u squared plus 5u plus 6. That is a quadratic. And so we can factor that using what we know. Well, I want two numbers that multiply to be 6, that add to be 5. That's positive 2 and positive 3. So I've now factored it using u, but now I just need to go back and plug in what I know that u is because my original expression is in terms of x. So I, of course, need my factored form in terms of x. So use x squared, I get x squared plus 2 times x squared plus 3. And there's my factored form from my original, which is what we call a quadratic form, because I was able to write it as a quadratic using a substitution. Let's look at another example here. We've got x to the fourth minus 1. Okay. This one kind of breaks the mold of our standard quadratic because we don't have three terms. We just have two. However, because we've got two terms and we're subtracting, that hints to us that maybe we'd be able to use a difference of squares or difference of cubes formula. And this x to the fourth, well, we could take a little substitution where u is x squared, and then u squared is x to the fourth, which is what we have right there. So we can think of this as u squared minus 1, and 1, of course, is the same thing as 1 squared. And there I now see a difference of squares. And my difference of squares formula is, let me write it out here, a squared minus b squared equals a minus b times a plus b. And so I can go ahead and factor this as u minus 1 times u plus 1. Well, now I can plug in what u is, which is x squared. I've got x squared minus 1 times x squared plus 1. And we're not quite done because x squared minus 1, I could think of that as a 1 squared again. This is a difference of squares again. So I can use this formula again where a is x and b is 1. This becomes x minus 1 times x plus 1, and then times the x squared plus 1. So there's my completely factored form from this x to the fourth minus 1, in which I used a quadratic form because I could think of this x to the fourth as x squared squared.